Hello Year 12, this is Miss Fisher here, and I hope you've all had a lovely Easter holiday and you're ready and raring to complete chapter 11. So chapter 11 is all about variable acceleration. So in chapter 9 and chapter 10, for some of you that have done that, my group, we're going to do chapter 10 after chapter 11. I know Mr. Bennett's group has already done chapter 10. Mr. Ali's group and Mr. Blunt's group, I think, are also going to do chapter 11 before chapter 10. Okay, so we can only use SUVAT if there is constant acceleration. That's really, really key. So constant acceleration, we use SUVAT. So what do we do when we have variable acceleration, when we have problems where the acceleration is changing? Right, well, we know, if you'd like to write this down please, this key point, that the velocity is the rate of change of displacement. So how do we write that? Velocity is the rate of change of displacement. So if we have V as velocity and S as displacement, how do we write the rate of change of displacement? Yep, well done. We write it as a differential. So it's ds, the rate of change of displacement with respect to time. The word rate is always to do with time. So very important, write that down please. Velocity is ds by dt. Also we'll have questions where we need to find acceleration. And acceleration is the rate of change of velocity. So we know if we were to look at, so we know acceleration is the rate of change of velocity. Well, we could write it like this, rate of change of velocity. We also know that velocity is the rate of change of displacement. So we could write it as dv dt on ds dt, or d squared s over dt squared. Okay, so make sure you've also got that written in your books please. Acceleration is the rate of change of velocity. Okay, so when we're looking at problems that have variable acceleration, we need to use what we call calculus. And what calculus means is either integrating or differentiating. Now, there is another way of writing this connection that we've just shown you in an easier way to remember this. So if we're going from displacement, again I want you to write this down please in your books. If we're going from displacement to velocity, we differentiate. And if we're going from velocity to acceleration, we differentiate. The opposite of differentiation we know is integration. So if we've got acceleration and we want to get velocity, we integrate. And if we want to get from velocity to displacement, we also integrate. Okay, so please write that in your books. Pause the video and write that down. S, displacement is always S, velocity is always V, acceleration is always A. And this we're going to use a lot, this connection here between displacement, velocity and acceleration. Okay, so let's look now at a problem. So this is the problem. I have got a cat called Snowball, he's about 6 years old, and he loves wandering the streets. And if we look at his displacement with respect to time, because he always comes back here for lunch, his displacement is given by this cubic equation. We've got time in seconds, displacement in meters. Okay, so question A asks us to find Snowball's velocity when t equals 2. So what we do, if I just write down the equation again for displacement, the first thing we're going to do to find velocity, well, we know velocity is the rate of change of displacement. So I'm going to differentiate this equation. So I bring the power down, take 1 off the power. I bring the power down, I take 1 off the power, so that'll just be a 1. 36t, well, a 1 there, bring the power down, take 1 off the power, be a 0, so t to the 0 is just 1. So if I just simplify this, my 2's will cancel, and I have this as my equation for displacement. Now I want to know what the velocity is when t equals 2. So to find my velocity when t equals 2, I'm just going to put that into the equation. So 2 squared is 4, 3 times 2 minus 36. I've got 12 minus 6 minus 36. And if I work that all out, I'll have negative 30 meters per second, or second to the minus 1. Now you might be thinking, well, why is it negative 30? Remember, velocity is a vector. It just means it's going in the opposite direction to the displacement. Okay, so that was part A. If we now look at part B, at what time will the cat be instantaneously at rest? Okay, so when it's at rest, think to yourself, well, what is the velocity when the cat is at rest? Well, the velocity will be 0 when the cat is at rest. So we have an equation for velocity which we worked out in part A, and this was the equation. So to find out the time when this is equal to 0, we've got a quadratic equation, and I want to solve this. Well, I notice that to make this equation easier to solve, I can divide each term by 3, and hopefully this will factorise. If not, I'd have to use the formula or complete the square. Let's just check if it factorises. T and T, 3 and 4 will give me 12. I want a negative 1 here, so it will be that. Or you might use a different method, the AC method, to factorise a quadratic. If you find factorising a quadratic difficult, please email your teacher for them to give you some advice. But by now, I'm hoping that this is an easy step for you. Okay, so we have 2 times. We have t is negative 3, or t is 4. Obviously, t equals negative 3 is impossible to have negative time. So my answer is t equals 4, and don't forget to put our units in seconds. So this solution doesn't exist. Okay, my last question about my snowball cat is, what is the cat's acceleration after 5 seconds? Okay, so we've got our velocity v, and we know that acceleration is the rate of change of velocity. So what I do is I differentiate v with respect to time. Let's move this up a bit. So differentiate again, bring the power down, take 1 off the power. Then I just put in when t is 5, and I get my acceleration to be 6 times 5 minus 3, 30 minus 3, 27 meters per second squared. Don't forget your units. Right, so that's a typical example on variable acceleration. And I'd like you now to have a go at this question. So this question was taken from exercise 11B, it's question 2. I'd like you to pause the video now, do this question. Imagine you're in class and we've put this question on the board for you to do. Have a go, and then I will go through the solutions. Okay, I hope you found that question easy to do. Let's just go through the solutions. Right, so you're given the displacement of the particle here, and it's moving in a straight line, and you want to find the velocity when t is 3. So to get velocity, it's the rate of change of displacement. So I'm going to differentiate, bring the power down, take 1 off the power. I'm then going to put in my value for t. In this case, t is 3. So if I put that in, I'll have 6 times 9 minus 8. And if I work that out, I will get 46 meters per second. Okay, the acceleration when t equals 2. So I've got my formula for velocity. To find acceleration, acceleration is the rate of change of velocity, so I'm going to differentiate. Put in t for 2, 24, take away. Oh, I made a mistake, apologies, you won't have this here. 12 times 2 is 24 meters per second squared. Obviously, when you differentiate 8, it will go to 0. Just checking, okay, that you didn't make that mistake. Okay, and next, please have a go now. Pause the video. Have a go at question 6. This is again from exercise 11B. It's the last question in the exercise. So pause, have a go, and I will go through the solutions. Okay, well done. Well done for having a go at question 6. You've got a printer, and the printhead is moving from side to side of the printer like this. This is your cubic equation for S with respect to time t. And you want to find the time it takes, find the distance between the points when the printer head is instantaneously at rest. So what would you do for this question? So I'm going to just pause the video for a second. Okay, question 6. Find the distance between the points when the printer head is instantaneously at rest. Instantaneously at rest. Well, we know that the velocity will be 0 when the printer head is at rest. So we know that the velocity is the rate of change of displacement. I'm going to keep the quarter outside and then differentiate everything inside the brackets. So bring the power down, take 1 off the power. Bring the power down, take 1 off the power. And the 30 will differentiate to 0. And that whole equation, everything here, will equal 0 when the velocity is when the printer head is at rest. Okay, I'm not going to times everything by a quarter in here. I'm just going to bring the 4 over to the other side. So the inside of the bracket will be equal to 0. And I want to factorise this quadratic to find my value for t. I notice that everything here is divisible by 6 to make it easier for myself. So I'm going to divide everything by 6 to get this equation. I hope it factorises. If I put a 2t here and a t here, well, the only way to get 2 is 2 and 1. So I'm going to put a 2 here and a 1 here. That will give me 4 and 1. I want them both to be negative to get my minus 5t. So solve each of these brackets. I get t equals half a second or t equals 2 seconds. Okay, now I would like to, that's the time that the printer head is at rest, but the question says to find the distance. So what can I do now to find the distance? Well, what I'm going to do is put the half back into the displacement equation and the 2 into the displacement equation, get the 2 answers and then subtract them. Okay, so when t equals a half, I'm not going to do the whole calculation, I'll leave that for you to do. You get 8.2 and my units, the question said that it was in centimetres, and when t equals 2, I put that into my equation for displacement. This equation here, I'm putting it into the original equation, and I will get 6.5 centimetres. Okay, if I subtract those two, I will get 1.7 centimetres. So the distance, if we go back to the question, the distance between the points when the printer head is instantaneously at rest will be 1.7 centimetres. Okay, well that's all my teaching now for 11B. If you've got any questions about what I've gone through, please email your teacher. And what I'd like you to do, please, for your work at home to check your understanding is 11B, questions 1 to 5. You can miss out question 2 because we've already done that, and question 6. Please mark and correct your work in a different colour, preferably green. Use the solutions on Active Learn, and please send a photograph of that work to me or your teacher that's set this video by the set deadline. Thank you for watching. I hope this video has been helpful for you, and all my future lessons will be like this. Keep well, stay safe, and see you again for the next lesson.